Good evening, everyone. Am I audible?
Yes, ma'am. Good evening, ma'am.
Thank you. So today we'll be starting with week 3. Hope my screen is visible.
Yes, ma'am.
Oh. So week 3 started with comparing structured programming with object-oriented programming. So in structured programming, what we actually do is we'll design these functions and procedures, and then we'll combine them to build something, whatever we want to build. So basically, we say that every program consists of two parts. One is algorithm and the second is data structure, right? And in structured programming, we'll focus mainly on the algorithms first. So data structure or how the data will be stored, etc., will be considered later. Okay. And in object-oriented design, which we are focusing on here, we'll identify the data first. We'll decide on what data we have to operate on, and then we'll design all the algorithms which we have to work on this particular data. So here we identify the data structure, then algorithm, just reverse of structured programming. So one example here given is about a simple web browser. If we have to design a simple web browser using structured programming, suppose it has some 2000 different procedures and we have some global data. So these procedures will manipulate this global data in order to work this web browser. And if we compare this with object oriented design, what we can do is we can have some 100 different classes. So you already know the concept of classes, right? In classes, what we do, some we will have some attributes or variables, and also we'll have some methods. So instead of having 2000 different procedures, what we can have in object oriented design, we can have some 100 classes, and each of this class will have about 20 methods. So this is kind of a better design. And if something is wrong, we just have to look into some class and identify where this problem is, and we can rectify the error in that particular class or object. So that is the difference between structured programming approach and object oriented design. Is that okay?
Yes, ma'am.
Yeah. So we'll start with a simple example of order processing system, just like our Flipkart or Amazon. So it basically, so what we are doing here is we are trying to identify if we have to design an order processing system, how can we do it in object-oriented design manner or that approach. So what we have to do, we have to identify the classes. What are the classes that we can have for this particular system? So items, orders, shipping address, payments, accounts, these are the classes that we are identified now. Now, inside the classes, this will have its own variables, right? And also some methods. Now, see what happens to these objects. So sometimes this item, an object of item, will be added to orders. Okay, so adding is a method, a verb, something we are doing. And then orders, if we take the case of orders can, we can ship some order. So once we place some order, it will be shipped, right? And we can later cancel the order. So these kind of methods should be there in order class. And in payments, either the payment will be accepted or rejected. So these are some of the things that act upon these classes or objects. So these are the classes that we identify, and these are the methods that we identify on these objects. Now we'll see how we can take this into our program. So let's see some of the terms associated with this. One is behavior. Behavior means what methods do we need to operate on objects, which is basically our methods. And what is state? State, we can say it is the information instance variable. So when you create an object of a class, so you will provide some values to the variables, right? The instance variables. So that can be called as state of the object, right? Suppose you create employee object, you give some name and salary or age, etc. So the value of that particular object can be called as state of that object. Okay, and here given this particular term encapsulation, we'll see later. Now, identity. So identity is something that will distinguish it from other objects. So each object will be different from each other. So that is one thing. So even in the case of identity, sometimes the two objects may have same state, which means the values will be same, but they are different. So we have to see this object has its own identity. Now these features will interact with each other, which they state and behavior and all. So using the methods, you can change the state of the object, right? Using mutators, you can change the state. You can change the value of an instance variable that you have set. Now, there are some constraints like this also. We cannot add an item to an order that has been shipped. So, once it is shipped, you cannot add that item to the order. Now, another thing is you can't ship an empty order. That is, that shouldn't be there, right? Once you place the order, only that order can be shipped. Now, there are a few more terms that you have to learn: dependence, aggregation, and inheritance. Just go through this. Okay. Now, dependence is one particular class may need, or one particular object of a class may need another class's object in order to do something. So one is dependent on another. One here order may need to check the account class in order to check credit status. So these two classes are dependent on each other. Okay, an item and account doesn't have any dependency. So basically we will try to minimize these dependencies, and the term is called as coupling. That is how we, but that we focus while we design these classes. We will try to reduce the dependencies as much as possible. Still, it won't be completely uh, avoidable. Other relationship is aggregation. Aggregation means, suppose we have a class, and if that class itself has an object of another class, then we can say it is aggregation relationship. Object inside another object. So in this case, order class may contain item objects. Okay. So just remember it as in class we have this instance variable, right? So in class order, you may have an instance variable called item some e. Okay. And then inheritance. Inheritance is something that we will see in detailed manner, where one class may be a specialized version of parent class, another class. For example, this express order and order. Order is a normal class, and express order can be a subclass of order class. So basically, express order will also serve the same function of order, but something extra will be there. In express order, maybe it may take only 2 days, and order may take 1 week. So this extra feature will be there for the child class. Extra methods to compute shipping charges, priority handling, etc. will be in the child class. Are the terms clear? Is that okay?
Ma'am, could you please explain aggravation with example?
Okay. Uh, just remember it will be something like this. Suppose we have class item. Okay. And suppose we have class order. Then in class order, if we have item Just like the variable, so suppose I am taking a string order ID, and if I have something like item I, then this relationship is aggregation. An object of another class is used in this particular class. Okay.
Yes,
Ma'am, shouldn't that be composition rather than aggregation?
Composition we have not discussed, right?
Yes, ma'am.
I am not sure about the term
Ma'am, I
exactly.
think
Yeah.
aggregation, when we speak about aggregation, we actually talk about collections or lists or wherein we have some objects which are in groups.
I'm not sure. We'll check that. Okay. The composition versus application. Or I'm not sure whether they are almost similar. I just don't recall it. Yeah. Any other doubts?
no, ma'am.
Then let's see the most important part, inheritance. So consider this particular class. I'll show this code later. First, let's see the explanation part. So we have this employee class, and this employee class has instance variables name and salary. They are private instance variables. It may have some constructors to initialize those values, then mutator methods to set the name and to set salary from outside the class. So these are public methods, and then we have accessor methods. Accessor methods to access these values of variables name and salary. Now, other methods we have is this bonus method, which will take this percentage and will calculate the bonus of an employee using this particular formula percent by 100 into salary. So this is the basic employee class. Now, now in a company there will be managers who will be special type of employees with some extra features. Now, what we will do is we'll not create a separate class manager with all the details. We will avoid repeating this detail. Instead of that, we'll create a class manager that will extend the employee class. So extend means it is going to inherit all the variables and all the methods from this particular class employee into this manager class now. And if you want to add something extra features we'll add here in the manager class. So manager may have some secretary, so we have another variable, an instance variable, to store the name of secretary. And here, for this particular secretary, we have this set secretary method and get secretary method as well. Just see the definition. Manager object inherit other fields and methods from employee. Which fields? Now manager will also have name, salary, and all these methods. Along with that, it has secretary, set secretary, and get secretary method. Every manager has a name, salary, and methods to access and manipulate this. Now we can call manager as subclass of employee. Employee is superclass. Another term is parent class and child class. Okay, is that fine? The basics of inheritance.
Ma'am,
Yeah.
Ma'am, could you please repeat which is parent class, which is
Employee class is parent class, and whichever class that extends the employee class is child class. Here manager is subclass or child class. Employee is parent class, manager is child class. Okay.
okay, ma'am?
Now, manager objects do not automatically have access to private data. So whenever we say that a class will get all the features, all the attributes and methods of parent class, it is except this private data. Okay. So in here you can see we have name and salary, and you cannot have a constructor in manager which directly set the value for name and salary. Instead, we have to use something called super from the child class in order to access the member of parent class. So here you see, for class employee we have this particular constructor for name and salary, name equal to n and salary equal to s. So this constructor will take two argument constructor will take two values to set these values. And here this is another constructor here which takes just the name, and here using this keyword it is going to call whatever the constructor this particular arguments match. So here you see this of n comma 500. So basically two arguments. So what will this do? This will invoke the two argument constructor of the same class, this of giving two values. Now this n will go for name and 500 will go for salary. And now comes to our main part where how the subclass or the child class will have access to the private instance variable of parent class. How we can set the value? For that, we can use the super method. So using super calls employee constructor. So here you see manager constructor. It is a three argument constructor for name, a double for salary, and SN for secretary name. Okay, and when you create the object of manager, you'll create manager some m is equal to new manager and giving three values for name, salary, and secretary, and how it is going to set the value using the super. For name and salary, it will call super of n comma s here, and this super call will actually call the to argument constructor of the parent class. Now for the name and salary, the values will be set, and secretary directly we can set here because it is coming from manager class only. So this is how you access the private variable of parent class. Getting it? Is that okay?
Ma'am, I missed that. Can you please repeat your last statement?
So see here. So we want to create an object of manager, and we know that we don't have even the subclass members also cannot access the private instance variable of employee class. So we want to set the value for name and salary now, but we can't directly do it. Instead, what we do is we'll call the constructor of the employee class from the subclass manager. For that, we have this super method. So using the super, we'll pass the values for name and salary, this n and s, and then this will invoke the constructor of employee and set the value for name and salary here. Getting it?
Yes, ma'am. Yes.
Oh. Now, we have already seen that subclass has more features than parent class. Subclass inherit instance variables, methods, etc. from parent class. Now, a very important concept that you have to remember throughout the course. Every manager is an employee, but not vice versa. Okay, so this particular principle, how we can add in the code So you can create an object of manager and assign it to a reference variable of type parent parent class employee here. So you see here the reference variable is of type employee, and usually we create object new employee, right? And for manager we will be like manager m is equal to new manager, but we can do something like employee is equal to new manager. This will also work because every manager is an employee. And there is something that you have to remember, because now remember this point. You can create an object of child class and give it to a reference variable of type parent class. And the opposite won't work. Manager m equal to new employee, you cannot do this. This is illegal. Okay. And now, yeah, I'll just go with the code part. Same code. We have class employee, private variables name and salary, two argument constructor, set name, set salary, get name, get salary. Here we have our bonus method. Here we have secretary in class manager, and this is our constructor. Here this will give a call to employee constructor, set secretary, get secretary, and this you just ignore now. Now in main class we have main method. Here I am creating an object of manager and reference variable is of type employee and passing name, salary, and secretary name. Okay, so this is going to invoke this particular constructor, and here the super of ns will give a call to this constructor, and the values for name and salary will be set, and then for secretary here. That's how the object of manager will be created. Okay, now that's fine, right? Is that okay?
Yes, ma'am.
Okay. Okay, I'll just go with the same flow. Now, just go through this. A subclass extends a parent class. Subclass inherit instance variables and methods from parent class. Kind of what is a summary? Subclasses cannot see private components of parent class. A subclass can add more instance variables and methods. And finally, this particular topic can also override methods. Let's see. Now, we know that here we have a bonus method, right? That is common for all the employees, that take a percentage and calculate the bonus in this particular using this particular formula, percent by 100 into salary. Just whatever the percentage of the salary, that will be the bonus. Okay. And if you want to if you want to change the way bonus is calculated for manager, what you can do is you can override the method. The term is override, or it's not like completely rewriting. Just for understanding, you can say that we are giving a new definition for the bonus method, new definition for the bonus method in the class manager. So here, if you see the function signature, what is function signature? We can say the function name and the argument itself can be called as function signature. If you see the function signature here, this is public double bonus float percent. Same. Here is same, right? Public double bonus taking float percentage. Now, this particular part, whatever that comes inside the braces, can be called as the definition for this method. Here you can see for class manager, we have given a new definition for bonus, a new formula. How is it calculated for manager? 1.5 into super dot bonus of percentage. So using the super keyword, you can access the method of the parent class. So super dot bonus, this will give a call to this particular bonus method because you are using this super keyword. Whenever you use super call, here this is super call constructor, right? And this is super keyword to call the bonus method of the parent class by giving the percentage. Anyway, we are finding the bonus of manager in a different way here. So we have given a new definition for the bonus method in class manager. But look at the function signature, it is same. So this is called as method overriding. What is method overriding? The function signature will remain same, but in the subclass you will give a new definition for the method. Getting it?
Yes, ma'am.
Okay. Now we'll see some more things here. Here we have created an object of manager, and here I am calling e dot bonus. I'm giving 10 as the percentage, and here the salary is 60,000. I'm running this program. So here we are getting 9,000. So how is it calculated? 1 point, which bonus method is used here?
The manager one.
Yeah, correct. So here we have used the bonus method of manager 1. So few things to remember here is, see the reference variable. Reference variable is of type parent, which is employee, and bonus method is present in employee class as well. Okay, so just think of the compilation stage. In the compilation process, what will happen is it will take this particular reference variable e here while trying to see whether bonus method is present or not. So e dot bonus, so during compilation it will check whether e, which is of type employee. Okay, now it will check in class employee whether a bonus method is present in employee class or not. Yes, it is present. So compilation will be successful. And during the runtime, when exactly the execution happens, when the object is created, the object is of type manager. And during the runtime, as the object is of type manager, now the bonus method of the nearest class, that is manager class, this bonus method will be taken. So that is how it works. So how it passes compilation check? Because here E is of type employee, even though it is of type employee, bonus method is present in employee class. So compilation is successful. Then in runtime during the execution, object is of type manager. So this bonus method will be invoked. So this is called as runtime polymorphism or dynamic dispatch. Getting it?
Ma'am, if bonus method was not present in employee, then it will give error, right?
Yes. Yeah. If bonus method is not present, then it will give error because, okay, let's see that as well. See, cannot find symbol. Anyway, here, okay, let's remove
We are
this.
using
Yeah,
super method
yeah,
updating the
you just keep it as,
no percent. I
okay, salary we can't access. We will use get salary. Hmm. Okay, this is the error that we should get. So now see, here in class employee, we don't have a bonus method. Okay, We don't have a bonus method, but in class manager we have a bonus method. Okay. Now, now E is of type employee and object is of type manager. And during compilation, now this is a compiler error, right? During compilation, when we reach this line e dot bonus, it will check whether bonus method is present in employee class or not. It is not present, so we will get a compilation error saying it cannot find the symbol bonus. Okay, so even though we say every manager is an employee, and if you try to access those variables or methods that is specific to the subclass using the reference type of the parent class, you won't be able to do that. Okay, this you have to remember. Is that okay? Then next thing I'll tell.
Yes, ma'am. Okay.
Yeah. Now, if you want to access it, there is one way. What is that? Typecasting.
Yes.
So what you can do is you have to convert this E into manager, changing the type of E into manager. Then you will be able to access the method from manager, the subclass now. Fine.
Ma'am, you're saying if bonus is not there in employee class
Mm,
and it is available only in manager class,
mm.
can access it through the main that is employee manager into E.
Yeah, we are
Then we'll
changing
be
the
able
type.
to, since it is available only in manager, then that is the way we can access it.
Right. We cannot directly access using the reference type employee.
But why we have to use a reference type employee? Because acha, manager is an employee and which is there in okay employee
Now
class.
it is
We,
just for
we can
concept
also use
purpose.
Why
manager.
can't we do manager dot bonus then directly?
Yeah, yeah. So basically, this I'm talking about the concept only, right? So here there is no use, but later on you will see you can have an array of employee array, and if you have more than one subclasses for employee, maybe manager, some assistant manager, something like that, you can store the details of all the employees in an array, and each of this special type manager, assistant manager, CEO, etc. may have bonus method implemented in its own way. And in the same array you can store all the different specialized employees, and you can run a for loop, and you can calculate the bonus method just by calling it. So according to which object you are created, the bonus method of each specialized version will be called. So that will be a use. Getting it?
Yes, ma'am.
Yeah. Now we covered this. Yeah, here it is given that particular same thing. So suppose you can have an employee array. It is of size 2. One of the members of this employee array is an employee type itself, and the other one is of manager type. So array of 0 is this particular E of type employee, and this one is of type manager. Now you can run a for loop, and you can call the bonus method. So according to which type your object is, that particular bonus method will be invoked. Clear?
In this, the manager m
Your voice is
equal
breaking.
to manager. In this slide, am I
Yeah,
audible?
better. Yeah,
In the slide, it's saying manager E equal to.
yeah.
So
This
should it
is a
be M?
type. Yeah, here it is
Okay,
AM actually.
okay.
So we have seen typecasting. Okay, now we have seen
Ma'am,
typecasting, but yeah,
ma'am, but the casting will fail at runtime when the object is not of type manager.
correct. So if object is of a different type and this particular E. So here the object is of type manager. If it is a different type and then if you try to typecast to manager, then that will raise an error. So in order to avoid that, what you have to do is, first of all, you can check whether it is of type manager or not,
Instance.
right? Yeah, you can use this instance of operator, which will check whether it is of type manager or not, and if only if it is returning true, then you can typecast and call the methods. So this is how you can deal with runtime errors.
Yes, ma'am.
Ma'am,
Yeah,
ma'am, is there any need of taking the reference variable E of type employee? Like, can't we directly just use the reference variable E of type manager and do, because there is like if the reference variable is of type employee, it does not means either we have to change it to manager or we cannot directly use it. So it's better to not just use that employee thing, like it is not serving in any way, or is it?
actually, yeah, just if you are taking one example, one object, then you will think that okay, it's not of no use. But when we deal with bigger programs and all, we will actually deal with a lot of objects, right? So in that
Yes,
case, it will be useful. Now, this is just an example to show the concept. So
okay,
suppose
okay,
we have a large array of different types of employees, which is like manager, CEO, etc., etc. Then that will be useful. So you will see this in future also. This is not. This is just one example I am telling you, but in the coming weeks you will see wherever this particular concept is useful.
all right, thank you.
Now, that is the concept of method overriding, and let's see method overloading. So, in method overriding, what was the specialty here? The specialty is the function signature is same, correct? The name, the arguments, etc. are same. Now, now see something called method overloading. Let's see what is the use of that first of all. We have this particular class called arrays, and it has sort method. Okay, and we can create array of any type, right? We can create double array, integer array, float array, any array. And if you want to sort that array, what you can do is you can just call the sort method. Arrays dot sort method. Arrays is the class, sort is the method. Pass the array. Okay, and D array here you see this is a double type, and if you see I array, this is of integer type, and the method that we are calling for both are same, correct? While looking from outside, it is same. We just see arrays dot sort, we are passing the array, double array. Here we are calling arrays dot sort, we are passing the integer array. We don't know how this is actually done, the sorting part. And if you see in the class arrays, how exactly this sort array is implemented. You can see this sort method, public static void sort. This takes a double array, and the logic to sort the array of double array is given here. And you can see another sort, and this sort method is taking an integer array and it is going to sort arrays of integer array. So in this manner, there are different sort methods inside this class arrays, which is going to take different type of arrays and sort and return the sorted array. Okay, so this is called as method overloading, where the function signature is different but the function name is same. Okay, name is same but signature or the argument type is different. I'll show a simple example. See here, we have this class shape, and here we have a method area, and here it is taking an integer a, some integer variable a. Give me a minute. Okay, so here see, we have area method, and it takes an integer variable a, and it is returning a into a square of a. Basically, 4 shape square, we are finding the area. And next we have another method again with the same name area, and it is taking length and breadth, two variables, two values, and it is returning length into breadth. Okay, and next we have another method area, same name, but the type argument type is different. It is taking a double variable, double value, and returning 3.14 into r, basically circle. Now, in the main method, what we are doing, creating a shape is, object of shape is, and then calling area method by passing the value. First one we are passing an integer 5, second two values for length and breadth, and this is a double value. So when you call s.area with 5, this is going to check whether shape has an area that can take an integer value. Yes, we have. So this particular area will be invoked. Okay, and for next we have two values 7 and 2. Okay, so we'll go here, it will check, okay, this area is not matching, it is taking only one value, one integer value. The second one is actually the matching area, so this will be invoked. And for the third, this is a float value, a double value, so here it will go, and this will be the area method which will be invoked when you call area with double value. So according to the type of the arguments or the parameters that we pass, that particular area method will be invoked. So all in all, what you have to remember is method overloading is where a particular class, or this can be within class and subclass as well. Now for easy understanding, I'll tell you this. Within a class, if we have multiple methods with same name but different argument types, then it can be called as method overloading. And return type we don't consider, okay? So changes should be here. Name should be same and argument type should be different. Is that okay?
Yes, ma'am.
So this concept is method overloading. Don't confuse this with method overriding. Method overriding is also called as inheritance polymorphism. Why is it so? Overriding comes into play only when we have class and subclass, correct? We are overriding, we are giving a new definition to a method in the subclass. At the same time, overloading is something where function name is same, but there will be change in the type. Not just the implementation, it includes change in the argument type as well. But in overriding, the function signature completely should be same. Now, one more thing to remember is this is also called as compile time polymorphism, while method overriding is called as runtime polymorphism, because which method to invoke is decided at runtime in method overriding, correct? According to the object, according to which object is created, it will decide which method to call. But at the same time, in method overloading, which method to invoke is decided at compile time. So this is also called as compile time polymorphism. Okay, clear?
Yes, ma'am.
Now,
Sorry, ma'am, I missed the part. What is the difference between method overriding and
mm,
overloading?
so method overloading is compile time polymorphism, which means which method to invoke is decided at compile time, and method, okay, let's note it down here.
The name will be same and argument will be different. And
Yeah, yeah.
in over multiple, sorry, overriding.
Name will be same. One second. Compile time. First thing is let's start with uh, loading. Here, name will be same, arguments will be different. Okay, and second is this is decided at compile time. So it is called as compile time polymorphism. According to the data type of the method that we call, we'll decide which method to invoke. And in runtime polymorphism or method overriding, here function signature is same, which means name and arguments, everything about function should be same, and this is decided at runtime. So we call it as runtime polymorphism. Okay, according to object creation. Clear?
Yes, ma'am. Thank you. Thank you.
Now you can go through this. Did I paste it? Yeah, go through this GitHub page so you can see all the topics in a detailed manner along with codes as well. So you can just run the code and see. Maybe it's not complete for all the weeks, but you can refer because till 7 it's over, I guess. Just check it out, okay? So next is multiple inheritance. Okay. So what is inheritance? Class extending another class. Manager class was extending employee class, right? Now consider this particular class C1, C2 and C3. And you can see in C1 we have a method public int f, and C2 also we have a method public int f. Now C3 extends C1 comma C2. So here basically what it is saying, C3 is inheriting C1 and C2. We have to see whether this is possible in Java or not. Can a subclass extend multiple parent classes? So here when you extend two classes and if it has same methods, same function signature, now when you create an object of C3, which f will be invoked? That will be a confusion. Okay. So because of this particular inheritance is a type of inheritance which is called as multiple inheritance is not possible in Java. Java doesn't allow multiple inheritance through classes. Okay, just focus on this words classes. Later we'll see this is somehow possible. But now for uh, this week you learned that multiple inheritance is not possible using classes in Java. Okay, the reason is when these two classes, the parent classes, whichever parent classes, if they have same methods, then which method to invoke is an ambiguity. So we don't have this particular concept of multiple inheritance. Is that okay?
Yes, ma'am.
Yes, ma'am.
Okay. Now, next topic is Java class hierarchy. So we said that we don't Java doesn't support multiple inheritance, but we have something called a tree-like structure in Java, where whenever we write a class in Java, it has a parent by default, which is actually the class object. So we have a class called object. This is not our object instance of a class. This object, capital O object, is itself a class that is lying at the top of the hierarchy of classes in Java. So whenever we write a class, every class will by default inherit this particular class called object. Okay, let's see this class here, class object. Or we'll see some other class. See this class string. You know, right? We have this class called string, which we use to create strings. So see at the top what we have java.lang.object. So string class is extending this object class. Okay, this is what it means. So almost, not almost, all the classes in Java extends this particular class called object class. And if you look at the class object, it has certain methods: clone method, equals method, finalize, get class, hash code, notify. We'll see these methods later. For now, focus on this equals method and toString method. We'll discuss these two methods. Equals method, what is a return type? This is a return type of the method, boolean. It indicates whether some other object is equal to this one. Basically, it is used to compare two objects. And toString, I have to see toString method. This is very important. The return type is a string. Okay. And returns a string representation of the object. So we'll see. When you call the toString method from an object, it will basically return a string in this format. It will give the class name. So using the get class, it will get the class. Get name is to get the class name of that particular object. Then it will add an at, then some hash code of that particular object. You don't give much importance anyway. Some unique value will be there. We'll see all this. For now, you understand, in the class hierarchy, Java class hierarchy, class object is at the top and it gives us certain methods like equals to string, etc. And as you now already learned the concept of method overriding, now you can say that in whichever classes we create, we can always override these methods however how we want. Correct? Sorry. So we'll see that this leave this particular statement. This is not actually correct. Now, when you print a particular object, what we will get? When you print something like println some object O, we basically will get the string representation that we saw here. So when you print an object, it will invoke this particular toString method and you will get the string representation of that particular object. Now, Okay, let's see some code and we'll go back after that. So before this, we'll go with the equals be there. Okay. Listen, here we have class date. Here we have three instance variables day, month, year. Now here we have the constructor to initialize the values for day, month and year. For now, leave this equals method. Now in class main, we have the main method. We have created objects date 1, date 2, date 3, date 4, etc. So you see date 1 is created using a new keyword. Now we have an object of date with values 10 to 2022 and date 2 again another object we have created with values 15 6 2023, date 3 10 to 2022 and here see date 4 is equal to date 1. So you might be remembering what we did last day, right? So date 4 and date 1 both are pointing to which object?
Same object.
Same object that we created here. Now, using this double equals, what we are trying to do? Here we are printing date 1 equal to date 2. Whether date 1 and date 2 are pointing to same object or not. That is what this is going to return. So double equals will actually compare the reference of the object. So date 1 and date 2, we are comparing date 1 and date 2 reference variable. Are they pointing to same object or not? No, right? They are not pointing to same object. So we are getting a false as output. Correct?
Yes, ma'am.
Now for date 1 equal to date 4, here we are getting a true. Why? Because date 1 and date 4 both reference variables are pointing to same object. So that is the use of this double equals operator to check whether two reference variables are pointing to same object or not. Basically for reference comparison. Is that clear?
Yes,
Yes.
ma'am.
Okay. Now,
Ma'am, if we write date one dot equals to date four, the in that format also it will be same.
sorry, how you want to see date 1?
Dot equals like argument date four.
Okay. But here we have overwritten the method, right?
Okay.
So in case here now this will behave like reference comparison. Same, you will get the same output. Why? In object, where we use our equals method. In object, the equals method will, it is not written here. Mm, I think it's not given here. Anyway, if you do not override the equals method, it will basically function like the double equals, just the reference comparison. Okay, just remember
Ma'am,
that
it's
as
there
well.
in second bullet point. Y x and y x dot equals
Uh,
y.
Still, it's just giving the definition of a symmetric relation. Mm, I think it's given in our slides. Is here itself. Right. You'll find it somewhere, but remember,
26.
anyway, yeah, it is somewhat. I mean, it is equal to. It will behave just like the double equals. Okay, just the reference comparison. If you do not override. Now,
If we uncomment those lines, then it won't work. Like to line number 12 to
no, then this will work according to this definition that we'll see. Here, anyway, everything will be. Uh, this is not a good example because we are comparing the content, right? We'll take this itself. Okay. See here now we have overridden the equals method. Let's see how it is actually overridden. Basically, we are trying to compare the content of two objects, two data objects. So first what we did, we are checking whether whatever the object that we pass here is actually of type date. Why we are doing this? Because the equals method from the parent class, which is object class, in order to work this as the original equals method from the object class, we have to maintain the function signature. So this is the signature in the parent class object class, which takes an object type. So we have to check whether our object is of type date, and if it is of type date, then only we will convert that, typecast that into date. Okay, and then we are checking whether two objects day, month, and year are equal or not. Okay, we are using an AND operator here. So if it is equal, then we will return it true. Return whatever that is given here, because we are using AND operator. The return type will be either true or false, right? So here, finally, we will return false in case of if it is not an object or if it is not equal. Anyway, we have to return a false here last. Now we are calling date 1 equals date 2. Date 1, date 2. So here we will go. We'll check whether this is of type date or not. Anyway, it is date. Now check whether day is equal to this day or not. No. So this will return a false. Okay. And then second one is date 1 equals date 3. Date 1 and date 3. So here we have day as 10 and month as 2 and year as 2022 in both objects. So this will return a true. That's why the output is true. Getting it? Just calling the method just like that. No, but it is actually method overriding because equals method is coming from the class object, and we are overriding the method in such a way that how we want the objects to be compared.
So here the this dot day points to date one.
This dot date, okay, yeah, we pass whatever we pass this date, this will be this d, and from where we are calling date 1, right? So date 1 will be this.
Okay.
Is that clear?
Yes, ma'am. The same thing by default method, both will be false. Right?
Sorry, in the same.
Like if
Ma'am,
you,
if we don't override that equals, then he is saying
Ha
that
ha
it will
ha.
be false.
Yes, yes, because then it will be reference comparison and it will be false. Both will be false.
Ma'am, if D is already an instance of date, why did we typecast it to date?
Because see here, we are taking it in the form of object, right?
Yes.
So we have to convert into date. Otherwise, we will not be able to access uh, anything from the date class. Just like we saw the bonus method there. If only the child class has the bonus method, we cannot access directly using reference type of employee, right?
Yes.
We have to typecast similarly.
and so that means there is double typecasting, right? So when we pass date two, that will be typecasted to object type, and then again we are converting it back to date.
Basically, this is just a holding. So here we have not typecasted. It's just like employee is equal to new manager. We're assigning just a holding, and here only we are doing the actual typecasting.
Okay, like object D equals to date two.
Huh.
So object could be a string as well.
You mean to say,
No, I think it throw error.
Yeah, the dot equals method supports comparison of string other objects as well.
huh,
What
Rather
you're
that's
than
the
saying is
string, we
if
same
can
type
make
is
a date
fine.
object.
what you're saying if it's the date is in any form, then it converts it to the standard date form and then it checks.
No,
No, no, no.
doesn't
See
happen
here,
that.
we are creating date objects. We are not using any inbuilt library or anything, any modules or anything. We have date objects here. This is our custom class. Okay, we are using this particular class, this object, and then compare it. If you pass any other type here other than the date type, then it will return a false. Directly will go here because this particular if will return a false, then we'll come here the next statement, then we'll get a false. If you try to compare date one with some other type, some string type or anything. Okay.
This
Ma'am, can you just
equals,
convert that object into date type in the overridden method equals? I think that should work.
Please repeat.
Ma'am, in the definition of equals, rather
Mhm.
than giving object, I'll say date D.
Yeah, then it will work, but the thing is, then it won't be method overriding. So, what is method overriding? So, you see the definition here boolean equals object is stating the function signature should remain as such, right? That is what we saw earlier. So, in order to behave in the same manner as we wish, so we have to maintain this signature as it is and then give definition for the equals method.
Oh, so if they ask us to use method overriding, then we have to use object, not date D. It has to be the same signature.
Yes. So it is given.
Now, if it is not of same signature, then equal to will not call this. It will only call default.
Sorry.
So if it is not overriding, then when we call equal to, then it will use the default equal to. function?
Mm, basically, equal to doesn't have any relation with equals method.
Okay, but it
No.
implicitly calling equals
It's like
method.
it behaves almost. It behaves similarly. The default implementation of equals method and equal to behave similarly, but they don't have any connection with each other.
Okay.
Ma'am, this equals method, is it a generic method for under object class?
Uh, we cannot say generic method, but yeah, as it is taking an object type, yeah, we can say.
Okay.
That's why we are typecasting every time we override the equals method because it's applicable to any type now because it is having the highest parent type. We can assign any type, right?
Okay.
Now, mm, yeah, this one overriding looks for closest match. So we have seen bonus method, right? So if we have bonus method in both employee class and manager class, then which bonus method will be taken? The nearest one is manager from the bottom. So that will be taken. That is what is written here. Overriding looks for closest match. Suppose we have again for equals method. If we have equals method in employee class and equals and no equals method in the manager class, then this will be taken similarly.
Now, can you repeat this again?
Okay, suppose in class employee we have equals method overridden, but in class manager we don't have an equals method. Okay, then if you still call equals method using two manager objects, then first we will check whether equals method is present in manager class. If it is not present, then it will go for the next one in employee class. So as employee class has an equals method, that will be taken. What if it doesn't have employee class doesn't have equals method? Then it will go to the object class. Okay. Remember, object class has equals method already implemented. Okay. Now we have class employee and class manager. Suppose class employee has equals method and class manager doesn't have equals method, then when you call equals method using manager objects, it will first check whether manager class has equals method or not. If it doesn't have, then it will go for employee class. It will check in employee class. Then that will be taken. It won't go directly to the object. That's why it is called as overriding looks for closest match. Clear? Did you get it?
Yes.
Yeah. Okay. Now, this concept of subtyping and inheritance. So, what is subtyping? Capabilities of a subtype are a superset of the main type. So, we said that if B is a subtype of A, if A is at top and B is here, and whenever we require an object of type A, we can use an object of type B, like this. So, instead of whenever we want an employee, we can always use a manager as well, right? Because manager has everything that an employee already has. So that is what subtyping is. And inheritance is basically subtyping is a concept that we can compare with the capability of subtype or the classes or any type. So what are the methods that a particular class is supporting? Those can be called or come under subtyping. And in inheritance, we basically focus on reusing whatever the code that we have. Okay. So in employee, we already have set name, set uh, salary, etc. We are basically reusing the same methods, right? So when we say B inherit from A, and also the method overriding thing. So when we say B inherit from A, manager inherit from employee class, and if we are changing the bonus method, we are basically changing some function of A in B, correct? That is what inheritance is. Let's see this in detail about
Ma'am,
DQ, Q and stack. Yeah.
ma'am, in week one, uh, during some session, I think someone had told, some TA had told that I mean, had given an example of a copier and a printer and uh, a scanner.
Mm-mm.
So what he told was, uh, I mean, a copier will inherit from scanner and printer. So basically, that is inheritance. But in real life, a copier is an instance of scanner and an instance of this printer. So I had a doubt in that, and regarding this, there is also a question in some activity in week one, ma'am. So will it be possible for you to take up that, ma'am? Because it was based on same concept, and I messed it up there. I mean, so will you be able to take that up, ma'am?
Mm-mm. Yeah, we'll check.
Okay, ma'am.
Which one? Do you remember?
Ma'am, I think it was in graded. I'm not sure.
Or graded? Graded, I can discuss. Mm. Okay, we'll take at the end, okay, after
Okay,
we
sure,
stop
ma'am.
streaming.
Ma'am, by the time I'll just search that question.
Haha. After we stop streaming, we can take it. Yeah.
Sure, ma'am.
Now let's go with this particular example, DQ. Maybe this is very similar to which one you explained now. So here also we have this Q. Let's start with Q. In Q we have this two methods, insert var and delete friend. Okay, and stack with two methods, insert friend and delete friend. And we have double-ended Q which support four methods, insert friend, delete friend, insert var and delete var. Okay, now here we have to find the subtype and inheritance relationship between these classes. If you see here, DQ has more functionality than Q and stack. From this itself, what you can fix, DQ will be subtype of these two types, correct? What is subtype? Subtype will always have more functionality than other types. So here DQ has more functionality than the other two types. So we can say DQ is subtype of these two types, correct?
Yes.
Yeah. And now inheritance, you see, can suppress two functions in DQ, and you can avoid using any two functions that you don't want, and you can use it as Q or stack. So when you already have definition for these methods, do we have to rewrite it? No, right? So you can use the methods that is available from the DQ for Q and stack. So this is the inheritance relation between DQ, Q and stack. So we can say that DQ, these both Q and stack will inherit from DQ and reuse whichever function that it wants. Q wants only insert var and delete friend operation. Stack wants only insert friend and delete friend. The other two functions it can suppress. So this is the subtyping and inheritance relationship between these three classes. DQ is the subtype of these two classes, and Q and stack are inheriting from DQ. And usually, what happens is this subtyping and inheritance will blur out each other. How? If you look at employee and manager class, those two types, there you can see manager is subtype of employee, and also manager is reusing whatever the methods and methods available from employee. There it is subtype and subclass, correct? But here it is different. Here DQ is subtype, but DQ is not inheriting from these two. Rather, Q and stack is inheriting from DQ. Getting it?
Ma'am, can you please repeat once?
See here, subtyping means that particular type, whichever subtype that we are referring to, that particular class or type should have more functionality than whichever classes or types that we are comparing to. So here you see DQ has more functionality than other two types, correct? So we can say that this is the specialized type, this is the subtype, DQ is the subtype. Understood?
Uh, DQ is the subtype.
Of these two types.
Okay.
Now, but in inheritance, when you look at inheritance, the concept of what is the concept of inheritance? We are reusing the methods or functionality that is available, correct? So if you look at DQ and Q, in DQ we have insert friend and insert rare method, delete rare and delete friend. And what does Q want? Q want only insert rare and delete friend method, which is already available in DQ. So what we can do? Q type can just inherit from DQ and use only those methods that it need. So reusing the implementation that is already present. So that is the concept of inheritance.
Ma'am, but we cannot have selective inheritance. We will have those extra features as well.
Yeah, just conceptually you can say we can avoid using other two functions and use only which is needed for Q. Correct.
Then what is difference between inheritance and overriding?
Please repeat.
Over overridden and inheritance both are same thing or is different?
Actually,
Overriding and hello.
overriding, yeah, got it. Overriding, this particular concept comes when we do inheritance.
Okay, it's come
Uh,
from inheritance. Okay.
your voice is breaking.
Yeah, madam. Overridden it come from inheritance.
Yeah,
So both are, yeah.
when you do inheritance, you can do
Yeah.
method overriding.
Okay.
Basically, method overriding and overloading all
Ma'am,
comes under the
because
concept of polymorphism.
Okay. Okay.
But they are related. It's not completely independent of each other, but they are related.
ma'am,
Uh,
Yeah.
so basically we are trying to say we are deriving the parents from the child here. We are deriving Q and stack from DQ.
Yes. Q and stack inherit from DQ. Q extends DQ, stack extends DQ.
Ma'am, then when the subtyping comes into picture, ma'am?
We say subtyping here because when we compare Q with DQ and stack with DQ, we can see that DQ has all the functionality of Q and
Ma'am,
more.
in if we see the other way, we can also say that DQ is having all the features of Q
Hmm.
and stack.
Yeah, it's of course it has.
Hmm.
But why we say it is a subtype? Because it has more functionality than Q and stack. So DQ is subtype
But
for Q and also stack.
Can we
but
also
ma'am,
say
multiple
uh, any child is a subtype of its parent?
Mostly all other examples you will see subtype is subclass. If you take employee manager class or anywhere, you can see that. But here it is different. This shows the exact concept of subtyping and inheritance. But in Java, what happens is the subclass will itself become subtype.
Okay.
Ma'am, that is where I'm getting confused because I'm taking this concept to Java and then mapping it there, and then I'm relating the two. But
Yeah, yeah,
what you are saying is a bit counterintuitive.
yeah. Understood. Why you are getting confused? I understood. But you just learned the concept of subtyping and here it is different. They are not same. They are different. You can see by this example itself.
Okay,
But
so
when it
we are
comes to
saying
Java only,
DQ because DQ is having more features
yeah,
than Q and stack.
yeah,
So it is subtype of Q and stack.
yes, correct.
And queue and stack have the some same behavior as DQ, then we say that queue is actually taking those behavior from DQ by means of inheritance.
By means of inheritance, very correct. Yeah,
Ma'am,
yeah, yeah.
here queue and stack we say they inherit because that some methods are same.
Yes, it has this DQ has whatever methods Q and stack needs. So you just have to inherit, right?
Yes,
Whenever a class has some methods that you need, you just inherit from that.
okay, we inherit and suppress some methods. That is what
Huh.
it is written in the slide.
Right,
But
right.
like practically, when we are implementing in Java class, then suppression is not possible, right? This so that is why that is different in Java.
Basically, you can say that. Yeah.
Yeah, theoretically we say that can suppress other
Mm,
functions, but
mm,
in
right.
Java class we can't do that.
Or use just those two methods which you need. This is possible. You just create an object of Q from DQ and use only insert var and delete
Yes,
from
ma'am, but
methods.
even if you use other things, it will not throw error.
Ah, right,
Java.
right.
Then we can't say that. Okay, so that is why there is a
Just for
difference.
conceptual, yeah, right. So as this is
Ma'am, ma'am,
our course is with programming concepts using Java, we have to learn everything.
ma'am,
Yeah.
ma'am, just hypothetically, I
Mm,
mean this in this slide you have written Q, stack, and DQ.
mm.
Let's say if I remove a method from Q, that is insert front, and a method from delete front. So my
Sorry, I
DQ
just
still
missed that
has.
one word. If we,
Yes, ma'am.
I just missed one word in between.
Okay.
Repeat the last sentence.
In this given slide, we have got three classes or maybe three types:
Mm,
Q, stack, and DQ. What I'm trying to do is from Q, I'm removing that method called insert rear,
mm,
and from stack, I'm removing that delete front.
mm.
But I'm not changing anything in DQ.
Okay,
So my DQ still remains a
subtype.
subtype,
Correct.
and my stack and queue still inherits because they want a selective features for themselves.
Correct. Yeah.
Okay, ma'am. Got it. Got it. Thank you, ma'am.
Fine.
Ma'am, so here subtyping and inheritance are opposite.
Not completely opposite. Rather, yeah, we can say that.
Yeah, but this
In
is
in this
theoretical.
particular example, this is the actual example where you can see difference between subtyping and inheritance.
Yes, but this difference is only in theory, right? It is not in Java, in programming language.
In Java, basically, it is similar. Subtype and subclass will be same mostly.
So only in theory it is different.
Mm. Yeah,
Sometimes.
correct.
Ma'am, one question.
Yeah,
Say
your voice is breaking.
both Q and stack inherit from DQ. Say, am I audible?
And now, please
Hello.
repeat.
Ma'am, when we say this, both Q and stack inherit from DQ.
Mm.
So say, let's pick delete front is the function or method we are inheriting. So would I be defining a method inside queue and stack, the same method, or will I be using the parents DQ's delete front?
You are saying Q and stack they inherit from DQ, but you are going to give a new implementation for delete friend. Is it so?
I'm just thinking through. Should I be using the DQ's delete front, or should I be defining one inside
You can
Q?
use the same one from the DQ itself because it will be same, right? When we deal with this kind of data structure, delete friend will remain, the operation will be same.
And in case if I want to override inheritance, I can do that inside stack or Q.
Still, we can say it comes under inheritance.
Okay. Okay. So overriding is
Man,
also possible.
Hi,
man,
yes,
Q and stack are
yeah, yeah.
inheriting from DQ, or DQ inherits from both of those.
Q and stack are inheriting from DQ.
Then Q and stack having less methods than DQ.
Yeah, yeah. But here, the conceptually, what we are doing is Q and stack. We have DQ, and we want Q and stack. Okay, so this Q and stack are inheriting from DQ and using only those method that it needs, not more than that. That's why we say can suppress
Okay,
two functions in
but
DQ.
having but Q and stack having both of them same functions, but they are using only those who are matlab, means the valid function for their
Correct.
definition.
Yeah. So you'll see subtyping again in interfaces. We basically say subtyping is we define the capability of something, some type. So when you learn the concept of interfaces, this will be more clear. So what we actually mean by capability of a type. Okay. Or you can just remember, I mean, understand in way like imagine we have a class and it is giving us some certain methods. Okay, and those methods can be called as capability of that particular class or type. Okay, so that comes under subtyping. So compatibility of interfaces, for now you just remember like this. Okay, this is the same. B, if B is a subtype of A, if every function that can be invoked on an object of type A can be invoked on an object of type B. Related with employee and manager, B is a type of A, which means manager is a type of employee. So we can say that any method that we can invoke on type A, which means type employee, can be invoked on type B, right? Always. Whatever methods that is available for employee is available for manager. So that we can say manager is subtype of employee. Inheritance is basically reuse of implementation. You just remember these terms, okay? Compatibility of interfaces, reuse of implementation. Inheritance will be more clear for you. Subtyping will be more clear when you learn interfaces, the concept of interfaces in week 4. Inheritance, reuse of implementation. B inherits from A if some functions for B are written in terms of functions of A. Just remember how we did bonus method. Using one idea hierarchy of classes to implement both concept blurs the distinction between the two. That is what happens in Java. Is that okay? Clear, right?
Yes, ma'am.
Okay. So access modifiers, Sir has discussed in detail in week 2, I guess. So I'm not taking that. Hope you remember we have 4 access modifiers: public, protected, default, private, etc. You just see Hold. You just remember this table, that will be enough. This table. Remember this table. Once you go through this, you'll remember automatically. You have to understand the concept of package to understand this. Hope you know what is package. When you group together classes into a folder, you can say that folder is a package. Okay. You know subclass, right? These terms, if you know, you can just go through this table. Okay. So I'm stopping for now. Okay. Do you have any doubt? That scanner question